Welcome to CP0. My name is Ninghui Li. I'm a professor of computer science at Purdue University. I'm also coach for Purdue's ICPC programming teams. So this is a university level programming competition. The last year, I have taught three competitive programming courses, CP1, CP2, CP3 at different levels. And this is a new course that aims at teaching programming to beginners. So the goal of this course, or rather the motivation of this course, is really dissatisfaction from other introductory programming courses. I look at quite a few of them online and have experience with others. I felt that they have some limitations and doesn't do a great job at teaching people to learn to program. So there are a number of reasons for that. One of the limitations that I felt is that there are some basic computing or programming idioms that are commonly used, but they are not sort of sophisticated enough to be worthwhile being called an algorithm, so they are often not taught. And oftentimes students are left to sort of figure them out on their own, which sometimes when you don't, then you write programs that are sort of not as elegant and as efficient. And another issue that I saw happen a lot is the assignment typically will assume students already know some material. Oftentimes it's implicitly, so it's not explicitly designed that way. But this is learning to program is like think about learning a foreign language. So when you already fully know a language, when you try to teach it to the other, oftentimes there are things that you don't realize you need to teach. Because it's already part of your knowledge. You didn't realize the beginner didn't know that. You assume this thing is already known, or you didn't think through in order to solve an exercise what are really every single piece of knowledge that's needed. So this is something that I'm trying to sort of correct. I'm trying to achieve that for every new assignment. At least there exists a way to solve the problem. There exists a fairly natural way to solve the problem where all the knowledge has already been taught. I know I will fail at that goal because I cannot anticipate every piece of knowledge that's needed. But I think because I'm intentionally trying that, hopefully that will happen relatively infrequently. And also, I want to use a problem-driven approach, which I feel it's better at teaching a lot of things. So essentially, you learn from doing things. So by using a problem-driven approach, I mean two things. First is every concept, every piece of knowledge I'm trying to teach is in the context of solving some programming problem. So most of the lectures will consist of me going through some example problems. Sort of, we look at the problem together, we think about how to solve them, and then we look at either the whole code or part of the code, the key part of the code, how to solve it. And second, there are extensive programming exercises. So my philosophy is to have a lot of small exercise instead of sort of you get one big project for every week when you start to learn the program. So a big project will be very useful later on when you learn to develop when you learn computer science. But at this beginning level, I believe it's better to have more smaller programming exercise so that you can exercise the programming ability and really sort of internalize that knowledge. And also, this course is really language neutral in the sense that I will use a C++ language, but only a fragment of it. And the reason I use C++, the most part is because it's input and output are very straightforward. So I'm using the stream input and output because I don't want to sort of having to tell. So if you use any other language, the input output will be a little bit more complicated and more verbose. And then in the beginning, then I have to tell you to just ignore that. This is how it works. So I try to reduce that to a minimum amount. So that's and the other reason is the standard library of C++ is very. I find it very intuitive and compared to, for example, Java. But we actually just use a little bit of the standard library. So most of the part of the course is really language neutral. So the part that we teach in this course also are applicable to Java and C, and to a less extent to other languages. But I believe most of the concepts you learn are actually really just about programming instead of any specific language. So as a result, we're not really teaching sort of enough piece of any single language, or we'll cover less than any other introductory programming course in terms of language features. So we will spend probably zero or at least very little amount of time on, for example, class, and really focusing on the procedural part of programming. So these are the topics that I plan to cover in CP0. So there will be 12 topics and 4 review sessions. So the review sessions will be videos recorded during the course, while the course is going on, so that I can look at the students' submission and see what are the problem, and maybe sort of debug some of the student submission. So those will be specific to each individual offering. But the other videos, I expect them to be stable so that they can be used for other courses. And I also plan to make videos for some of these topics publicly available on YouTube. Probably the first 6 topics, but I'm not quite sure about that. Yeah, so you can read the topic. I guess that you can see there are quite a few topics about arrays. So topics 3 to 6. So essentially, we use array to store data, and then we use a for loop and if statement to manipulate the data. So it's really about the practicing how to express ideas or procedures for solving problems into code. Oh yeah, so another thing about the relationship to AP Computer Science A, so there's a large overlap with AP Computer Science A. So I believe I try to cover all the algorithmic programming aspect of AP Computer Science A, not so much the Java class, the object-oriented inheritance, not that part. But we cover the other concept, and at the same time, you are doing a lot more programming exercise. So the programming exercise will be a lot harder than the one you will encounter in a typical AP Computer Science A course. So this is a grading policy for those of you who are taking this course for credit. So it's a 2-credit course. There are 12 topics. Each topic has one problem set. So this will be set out as a competition on HackerRank. So we're going to look at the problems in the competition on HackerRank when we talk about, when we use that as example problem. But if you're taking the course, we'll set up a separate competition, even though it's exactly the same problem. But we'll set up a separate competition so that it's easier for us to collect the grade. So everyone can use the sort of the default competition on HackerRank for practice, but those won't be graded. We will post the link to competitions in Piazza for those who are taking the course. And every problem set contains anywhere from 6 to 10 problems. So I know the first 3 topics, they all have 10 problems. So we'll try to have around 10 problems. But some of them maybe we have fewer, especially toward the later topics where the individual programming assignments get a little bit harder. And every problem set has a total of 100 points. So if you solve all of the problems, you get 100 points. So then if you solve every problem in the course, you get 1,200 points. And the grading scale is you need 900 for an A, 700 for B, and 500 for C. So all the example problem also have, I think each example problem count as 5 points. So in a sense, and each of example problem, we will provide a code solution. If you understand them, you can sort of just copy and paste them in, and then you will get some minimum amount of points sort of towards your total. Okay, so that's it for now. And next video, we are going to look at the first example.